All right, let's talk about the pH today. First, let's take a look at the water dissociation. Okay, that's the reaction, and the water dissociates into a proton and a hydroxide. Okay, when this reaction reaches equilibrium, and we can calculate equilibrium constant. Okay, that's the equation. Okay, this is a proton concentration, hydroxide concentration is a water concentration. Okay, then let's make a rearrangement. Okay, we got water water dissociation constant Kw. Okay, Kw equal K is equilibrium constant multiplied by water concentration. Water concentration here is constant. It's 55.5 molar, and so we got the Kw after calculation, we get the Kw equal to 10 to minus 14 molar square at 25 degree. That means Kw is a temperature dependent. Okay, Kw is also called water ionization constant. In the situation of pure water, the proton concentration and the hydroxide concentration are the same. Okay, so pure water contains the equimolar amount of proton and hydroxide. Okay, therefore, water concentration equal hydroxide concentration equal Kw to half, to the power of half. Then we got 10 to minus 7 molar. Okay, this is a concentration of proton of pure water. Okay, so let's take a look at this. Okay, if the concentration of proton equal 10 to minus 7 molar, so that's it's neutral. Okay, if the concentration of proton larger than 10 to minus 7 molar, it's acidic. Okay, in this case, proton concentration is higher than hydroxide concentration. Okay, if the proton concentration is smaller than 10 to 7, this is the basic. In this case, hydroxide concentration is larger than proton concentration. It's an acidic solution. All right. Okay. Now let's take a look at the pH. Okay. When we take this let pH equal to minus log proton concentration. Okay. Then we got a small number. Okay, so easier to manage. Okay, in this case, if the proton concentration equal to 10 to minus 7 molar, the pH equal to 7. Okay, that's neutral. Okay, there's a common knowledge. Everybody knows that. So if the pH concentration larger than 10 to 7 molar and pH is smaller than 7, it's acidic. Okay, more protons, less hydroxide, it's acidic. If the proton is smaller than 10 to 7 molar and pH larger than 7, so it's a basic. Okay, and so next, and this pH can be easily determined in a lab by a device called the pH meter. Okay. Okay, let's talk about the pH of a weak acid and this Henderson Hasselbatch equation. Okay, so then we start from here. We know that Ka acid dissociation constant equal to proton concentration, the product of proton concentration and the A minus is the acid, okay, and divided by HA. Oh, okay. Let's take a look at this dissociation reaction. Okay, basically, if the HA is a weak acid, after dissociation, we know that they become a proton plus A minus. Okay, this constant is come from here. Okay, after rearrangement, that we calculate the concentration of a proton equal this Ka multiplied by this quantity HA, the concentration divided by A minus. Okay, and when we replace this one into this equation, okay, then we got this equation, pH equal minus log Ka plus log A minus over HA. And finally we got this one. This is called the Henderson Hasselbatch equation. pH equal pKa plus log A minus concentration divided by acid concentration. Okay, in this equation, when the A minus concentration equal to acid concentration, HA concentration, pH equal pKa. So of the weak acid. All right.